In 1935, the management of the renowned American aircraft manufacturer Consolidated Aircraft Corporation decided to move its headquarters and production facilities from Buffalo to sunny San Diego. However, not all the employees were on board with such a long-distance move. Among those who decided to stay behind were the company's vice president, Lawrence Bell, his assistant, Raymond Whitman, and the chief engineer, Robert Woods. This trio went on to found a brand new company. They named it Bell Aircraft. The founders managed to stay on good terms with their former employer. This helped them score some lucrative contracts to build various parts and complete subassemblies for Consolidated Aircraft. This really helped the young Bell Aircraft get on its feet quickly. Before long, though, just being standard subcontractors was not enough for the ambitious management team. The company's engineers took a gamble on a much more serious and large-scale project. They started designing their own airplane. The design team, led by Robert Woods, took a highly unconventional approach to developing this new aircraft. In their brainchild, which eventually became known as the YFM-1, they incorporated a host of progressive and frankly incredibly bold ideas. In the early stages, this project was driven purely by the design team's own initiative. They operated without any official contract from the military. Robert Woods' ultimate goal was to create an incredibly fast aircraft with heavy cannon armament. At the same time, he wanted it to maintain excellent flight characteristics. Inside the factory, engineers simply referred to it as the Model 1. It really was Bell's very first aircraft design built entirely from scratch. That made the whole venture even more audacious. A brand new company was betting virtually everything it had on one radical, unproven idea, and doing it before a single military contract had even been signed. That is exactly how the radical layout came about. Instead of putting the massive 37mm cannons in the usual spot inside the fuselage, they mounted them directly into the engine nacelles. These M4 cannons fired straight ahead. They were installed in the forward sections of both nacelles. Interestingly enough, actual gunners sat right next to the weapons. While they did have the ability to aim the cannons at a target themselves, their primary job was to continuously reload them. Each gun was supplied with 110 rounds of ammunition. Because of this highly unusual layout, the engineers had to move the propellers to the rear. This turned them into pusher props. Meanwhile, the front sections of the engine nacelles were given a slightly pointed and perfectly streamlined shape for optimal aerodynamics. To power the aircraft, they selected the formidable Allison V1710-13 engines. They cranked out a solid 1,133 horsepower each. This was a very respectable figure for the era. There was a clever, if complicated, twist to how that power actually reached the propellers. Since the engines themselves sat buried well back in the wing roots rather than out at the nose of each nacelle, the drive had to run through roughly 5-foot-long extension shafts all the way back to the pusher blades. It sounds like a recipe for trouble. Yet, oddly enough, this particular piece of engineering turned out to be one of the few parts of the whole aircraft that almost never gave the mechanics any grief. The end result of all this hard work was a fighter with an absolutely unique concept. In the press, it was proudly advertised as a mobile anti-aircraft platform and an escort fighter. It was designed specifically to intercept enemy bombers at extreme distances. These were ranges that standard single-engine fighters simply could not reach. This airplane was a major breakthrough. The YFM-1 was an incredibly innovative project. It combined a ton of technical features that military aviation had never seen before. Some of those solutions were actually never used again in aviation history. Thanks to its sleek and frankly futuristic design, the Bell Airacuda looked radically different from any other combat aircraft of its time. Just how large was this thing? Nose to tail, the Airacuda stretched almost 45 feet. Its wings spanned at nearly 70 feet from tip to tip, covering close to 600 square feet of area. Those are the kind of numbers you would expect from a compact medium bomber, not a fighter, however heavy. As Major Alexander P. de Seversky wrote in his book Victory Through Air Power, the Bell Airacuda is a tremendous technical achievement. However, calling it an escort fighter is somewhat of a misnomer. That role requires a completely different weapons configuration. Given that its maximum firepower is directed straight ahead, this aircraft would be incredibly effective specifically as a dedicated long-range interceptor. It is worth taking another look at the fighter's unique armament. The 37mm M4 cannons, along with their gunners, were housed right in the forward section of both engine nacelles. The gunners could technically aim the weapons themselves, however, their main job came down to loading the heavy shells. These were taken from the 110-round magazines stored right there in the nacelles. Altogether, the crew of this unusual fighter consisted of 5 members. First, of course, was the pilot. Next were the 2 gunners stationed inside the engine nacelles. Fourth was the navigator. He had another incredibly important job. He controlled the defensive fire using a complex Sperry fire control system. Interestingly, this system was originally developed for ground-based anti-aircraft guns. It used stabilized gyroscopes and ultra-precise optical sights. Finally, the 5th crew member was the radio operator and gunner. He manned a pair of machine guns mounted in special blister fairings in the mid-fuselage. His main job was to protect the aircraft from rear attacks. The pilot and navigator sat right in the nose of the aircraft. They were in a spacious cockpit with excellent visibility thanks to the extensive glazing. Right behind them was the radio operator's station. In the center fuselage, engineers incorporated 2 firing positions. These protected the aircraft from attacks from above and below. Specifically, that meant a retractable turret up on top and a tunnel-style mount underneath. Each one built around a .30 caliber machine gun fed by 500 rounds of ammunition. There were solid bulkheads between the crew stations. However, there were no completely sealed or isolated compartments. This offered one huge advantage. During long flights, the crew could move freely throughout the aircraft. The gunners could easily swap places with each other. The pilot and navigator could do the same. If a nacelle ever had to be abandoned mid-flight without an actual bailout, there was even a slim crawlway built into the wing's leading edge, letting a gunner scramble back to the safety of the fuselage. To avoid having to shout over the roar of the engines, the aircraft was equipped with an onboard intercom system. On top of all that, the Airacuda held a genuine first for an American fighter. It was fitted with its own auxiliary power unit, letting the crew run instruments and electrical systems without needing either engine actually turning over. The design for this unconventional heavy fighter, designated the Bell YFM-1, was presented to the American Military Command in late 1936. At first, the generals thought its appearance was far too bizarre, but the military pilots absolutely loved the concept. To see if the aircraft was as good in practice as it was on paper, Bell received a contract to build the first fully functional prototype. Interestingly, a slight mix-up happened during the paperwork process. The FM-1 designation was actually already slated for another aircraft. This was the carrier-based Grumman F4F3 fighter. It was just gearing up for production at General Motors plants. Obviously, having 2 completely different aircraft with the exact same designation was a recipe for confusion. So one of them had to give it up. As it turned out, those letters FM stood for Fighter Multiplace. Once the paperwork mix-up finally got sorted, that particular designation was never handed to another American aircraft again. In the end, the Airacuda remained the one and only fighter, multiplace the U.S. Army Air Corps ever fielded. Meanwhile, the U.S. War Department put out an official press release. It stated that no other recent aircraft had sparked as much intense interest as the Bell YFM-1. The military believed that a multi-seat fighter had massive potential. This was especially true given the rapid progress and increasing speeds in global aviation. The main mission of the new YFM-1 was supposed to be protecting and escorting the famous B-17 heavy bombers. These were just starting to ramp up in mass production at the time. Experts specifically praised the incredible firepower of the fighter. They also praised its high level of comfort. This allowed the crew to conserve their energy during long and exhausting flights. Work on this twin-engine beauty at the Bell plant moved surprisingly fast. As a result, the first prototype rolled out on July 19, 1937. Looking at its sleek, aerodynamic lines, few doubted its future success. Chief Test Pilot Benjamin Stanley Kelsey had the honor of taking the aircraft up for the first time. He was eagerly awaiting the historic moment. Soon after, the prototype was transported to the Buffalo airport. That is where, on August 28th, the new fighter took to the skies for the very first time. During its maiden flight, the aircraft handled smoothly. It did not hold any nasty surprises. Still, it was too early to celebrate. Drawing any real conclusions about the combat capabilities of the YFM-1 was simply out of the question for now. Lieutenant Kelsey continued the flight test program, and that is when the first major problems started cropping up. The pilot discovered a fatal flaw. If one engine failed, the aircraft became virtually unflyable. The massive airplane, known as the Airacuda, would instantly lose stability. It would snap into a deadly spin. Engineers tried to mitigate these critical handling issues. They did this by experimenting with reduced engine power. It soon became clear that you could basically write off the maneuverability of the Airacuda. Despite its clean aerodynamics, this fighter turned out to be way too heavy and slow. It handled more like a sluggish bomber. If engaged by fast enemy fighters, the Airacuda simply could not hold its own in a dogfight. On top of that, a meager bomb load of just 600 pounds made it practically useless as a fighter bomber. That load was made up of 20 small 30-pound fragmentation bombs tucked away inside bays built into the wings themselves. But the worst part was that the absolute pride and joy of the designers, the massive 37mm cannons, turned out to be downright dangerous to their own crews. When fired, they quickly filled the cramped nacelles with thick smoke. Worse still, in an emergency bailout, the gunners were stuck in a death trap. Right behind them were the huge, spinning pusher propellers. To keep the crew from getting caught in the props while bailing out, engineers actually had to design a special emergency system. This system was just to jettison the propeller blades in flight. The Allison V-1710 engines worked almost flawlessly on other aircraft. But on this fighter, they lacked adequate ground cooling. Because of this, the aircraft literally had to be towed out to the active runway. Only then could the Airacuda start its engines and begin its takeoff roll. But even at altitude, engine overheating was a regular occurrence. Even though engineers had planned for turbochargers, this giant made its first flights on standard carbureted V-1710-9 engines. Each of these was pumping out 1,000 horsepower. Later on, when the turbos were finally integrated into the newer YFM-1 variant, they constantly suffered from faulty regulators. This led to some pretty terrifying situations up in the air. The final straw was an in-flight explosion during a routine test flight in September 1939. At that point, it became crystal clear that curing the teething problems of the engines was not going to be an easy fix. Despite a massive list of technical flaws, only 2 of these aircraft were ever lost to accidents. One of those incidents happened during a final test flight over the Bell Company airfield in Buffalo. This was right before the aircraft was scheduled for delivery to the military. The accident took place on June 21, 1940. At the controls were Bell engineer and pilot John Strickler, along with co-pilot Brian Sparks. He was serving as the chief test pilot at the time. Following the flight plan, they intentionally put the aircraft into a spin, but suddenly they ran into a serious problem. The airplane flat out refused to recover. Despite the desperate efforts of the crew, the aircraft would not respond to their control inputs. The rudder felt jammed solid. Realizing how critical the situation was getting, Sparks killed the engines. He waited for the propellers to stop spinning so he could safely bail out. Because of the tandem cockpit layout, he had to go first. But things went wrong. He struck the tail section on the way out and broke both his legs. Meanwhile, the rudder unexpectedly broke free. Strickler was still in the cockpit. He decided not to jump. He opted instead to attempt a dead stick landing. By that point, however, the aircraft had lost way too much altitude. There was 0 time left to restart the engines. Miraculously, Strickler walked away without a scratch. He wrestled the heavy fighter down for a rough, forced landing right in a farmer's field. Unfortunately, the Airacuda was damaged beyond repair and had to be written off. Problems plagued other variants too. All 3 Airacudas equipped with tricycle landing gear suffered serious accidents. The most tragic incident happened during a cross-country flight. It went from Chanute Field in Illinois to Keesler Field in Mississippi. This happened on January 22, 1942, and the wreckage came down roughly 4 miles southwest of the town of Dewey, Illinois. Mid-flight, a fuel line suddenly ruptured. This instantly sparked a massive fire. Investigators later determined that this catastrophic failure was caused by severe airframe vibration at high speeds. There was no way to extinguish the fire in the air. The pilot and flight commander made the only call they could. They decided to bail out immediately, but tragedy struck. The pilot's parachute failed to open and he was killed. Experts suspect he may have hit the tail section on the way out. He might have been knocked unconscious. Remarkably, this was the only fatal accident in the entire flight history of the controversial aircraft. The official accident report was a damning indictment. It stated that the aircraft's inherent design flaws caused constant maintenance nightmares. It also recommended that flights in the type be strictly limited. Despite this grim track record, the heavy fighter still managed to pass its factory tests. In 1938, the aircraft was officially turned over to the military. It was ready for final, rigorous evaluation. Surprisingly enough, United States Army Air Corps representatives came away with a mostly positive overall impression. They liked the YFM-1 flight characteristics. During flight testing, the aircraft hit a top speed of 304 miles per hour. This was at a hefty takeoff weight of 19,070 pounds. Its service ceiling was impressive. The fighter climbed to an altitude of nearly 32,800 feet. Its maximum range reached about 1,790 miles. However, this optimistic outlook was severely undermined by the aircraft's poor maneuverability. It was weighed down by a massive amount of complex internal equipment. The airplane was severely overweight. This made it incredibly sluggish in the air. Then there were the armament issues. Firing the powerful 37mm Madsen cannons proved to be a nightmare. These cannons were not even installed on the very first prototype. The problem was that the two cannons were spaced so far apart. Convergence became a major issue, drastically reducing firing accuracy. Yet despite all these glaring flaws, the military still believed in the project's potential. They issued an official order for 10 more pre-production fighters. These were of the updated YFM-1A variant. Engineers hoped to implement a series of major improvements on these airframes. They wanted to finally make them fully combat-ready. It's worth remembering just how ambitious the original vision had been. Larry Bell wanted an aircraft that could hit roughly 300 miles an hour at 20,000 feet, relying on fully functional turbo superchargers to get there. But those early turbo units kept proving alarmingly volatile on the test stand, prone to overheating and even outright explosions. That track record made the Air Corps deeply nervous, and it is a big part of why the turbochargers kept getting stripped out of one variant after another. The original plan was for the first 8 aircraft to get Allison V1710-13 engines. These were specifically adapted to work with General Electric B6 turbochargers, but plans changed during production. Ultimately, these aircraft were fitted with an upgraded version of the engine, the V1710-23. Later on, while still on the assembly line, they decided to drastically alter the design. They modified 2 YFM-1 airframes. Under a new contract from October 1939, the complex turbochargers and their control systems were stripped out. Non-turbocharged V1710-41 high-altitude engines were installed instead. This updated version of the aircraft was designated YFM-1B. This new engine could put out a solid 1,090 horsepower at altitudes up to 13,100 feet. They achieved these numbers by increasing the supercharger gear ratios. This allowed the engine to run much more efficiently in thin air. Here is a fun fact. This variant actually used the exact same Allison V1710-33 engines that were previously installed on the very first Curtiss XP-40 fighters. At the time, Allison was paid $1,690 for each of these engines. The production aircraft began entering service in 1940, with deliveries trickling in from February all the way through October of that year. But the military was in for a major disappointment. Build quality was noticeably worse than on the prototype. This immediately took a toll on overall flight performance. The Military Acceptance Board was particularly dismayed by the top speed. The aircraft could barely hit 280 miles per hour. That fell well short of the high standards set for the new fighter. On top of that, the heavy fighters and flight stability still left a lot to be desired. Despite all these glaring issues, the U.S. military still managed to form a single squadron. This squadron flew the Airacuda from 1938 to 1940. Even though funding had already been allocated to equip 2 more groups, the additional aircraft were never purchased. Plagued by constant mechanical breakdowns, these fighters quickly earned the nickname Hangar Queens. Toward the end of their short career, Airacudas were mostly used for photo missions. and because of their terrible reliability, they always had to be escorted by a chase plane just in case. Eventually, Command decided to just disperse these aircraft across various military air bases. This gave local pilots a chance to log some flight time in some truly exotic hardware. That is how the planes ended up at Langley Field in Virginia, Maxwell Field in Alabama, Hamilton Field in California, and Wright Field in Ohio. One YFM-1 airframe, serial number 38-488, was even put on display at the 1940 World's Fair in New York. It was wearing the markings of the 27th Interceptor Squadron. By that point, however, the aircraft had logged barely any flight hours. This was because almost nobody actually wanted to get behind the controls of this bizarre and deeply flawed fighter. Engineers tried to salvage the project. They pitched a few different upgrade options for the Airacuda. They wanted to redesign the airframe itself and drop in significantly more powerful engines. The goal was to finally make the aircraft fully operational, but all of these proposals were ultimately rejected. In early 1942, despite genuine fears of enemy bomber raids, all 9 surviving airframes were pulled from reserve. They were then ferried to the training center at Chanute Field in Illinois. There, they were assigned to the 10th Squadron and used exclusively as ground training aids for new air crews. By the end of 1942, the story of this aircraft came to an end. All remaining Airacudas were permanently written off and sold for scrap. To get a better sense of how this unusual aircraft evolved, it is worth taking a look at its variants. The very first prototype was designated the YFM-1. It featured a retractable conventional tailwheel landing gear, along with fuselage cutouts for teardrop observation blisters. This was followed by an updated version known as the YFM-1A. On this model, designers decided to delete the blisters. They opted instead to add turbochargers and significantly larger coolant radiators. Then, in 1940, the final variant of the aircraft rolled out, designated the YFM-1B. This fighter was slightly longer and featured modern tricycle landing gear, but it was also fitted with less powerful Allison engines. The forward cockpit glazing was updated as well, swapping the complex curved glass for simpler, more reliable flat panels. With all these modifications, the fighter grew so massive that it started looking more like a conventional medium bomber, such as the Douglas B-18. In total, only 3 airframes of this final YFM-1B version were actually built in 1939. After this, production of this ambitious but highly controversial aircraft was shut down for good. All told, counting the original prototype, only 13 Airacudas were ever built. Still, the program was not a complete dead end. Chief Engineer Robert Woods carried hard-won lessons about unconventional engine placement straight into his very next project at Bell. That aircraft, the P-39 Airacobra, also broke with tradition by mounting its engine away from the nose. Unlike its temperamental predecessor, though, the Airacobra went on to be built by the thousands and flown in combat across multiple theaters of the Second World War.